I am Lauren Chenarides, and I am an assistant professor in the Morrison School of Agribusiness. I graduate. Oh, do we have somebody on the line? Something in the chat? Okay, just too much technology. So I joined ASU in 2017. I graduated from Penn State with my PhD in agricultural economics. And so this is I'm in my sixth year here. And Morrison School of Agribusiness is in the business school, W.P. Carey. So I'm going to be talking to you today about scanner data and applications of scanner data to food policy research questions. In ag economics most broadly, and we can think about the discipline being broken up into development, resource economics, and then agribusiness or food policy. And I've kind of found a home in the last bucket, food policy research. So let's see, I've been using this data since 2011, so for quite some time. Here's a rough sketch of our talk today. I'm going to go through just kind of like the semantics of it. This would be dangerous in my household. Okay. And then I want to spend a majority of the talk talking about the architecture of the scanner data products, because it's quite cumbersome to use. But I think once that people have a handle on how they're structured and how to work with such large data, the possibilities are endless. And then I'm going to give some examples of how scanner data has been augmented by linking it with other data sources. So like with SNAP and things like that, you can, I don't think I have an example of that, but I can talk to it. That's where I think a lot of the beauty of scanner data can be used. And then I will conclude with how to access it at ASU, and then questions. Great. So technically speaking, scanner data is observational data, and it's generally panel data, panel in the sense that it tracks the same unit over time, whether that's a retailer or a household. And it records for the retailers sales in the form of quantities and prices of food products sold. Actually, this particular data product that I'm going to be talking about has products in addition to food items. And for the retailer data, it looks at collecting these records at leading food retail outlets across the United States. And then that's the retailer data. And then the consumer data looks at products purchased by a representative sample of US households. There's approximately 200,000 households that we have purchase records for. And these are purchases for food consumed at home. So anything at a retail establishment. We don't include things like food service in our data, for the scanner data. There are two primary data proprietors, so the people that really consolidate the data, and Nielsen is one of them. I'm going to be talking about that data today. There's also a similar data product available that's collected by Information Resources, Inc., or IRI. The difference in accessing these, the difference between the two is in the accessibility of the data. Nielsen data products are available for academics through an academic subscription, and that is organized by the Kilt Center for Marketing at the University of Chicago. The data that's through IRI is really only available through research collaborations with the USDA. But Nick, because you work on SNAP issues, that might be also, you might find that to be advantageous, understanding the process here, and I'm happy to talk to you about that afterwards. All in all, this data is enormous. I think there's about 12 terabytes of data just for the years 2004 to 2020. Yeah, 2020. So, and that's you can't really store that on your computer. So I want to talk to you about how to bring the data down, how to merge the data, maybe even just talk a little bit more about what to do to manage all this data. A little history of the scanner data products. Primarily, they were, the data generating process is everything. And so understanding that these data were really collected to be used by industry for market research it is an important thing to consider when looking at these scanner data products. But because they, research economists like myself, an agricultural economist, because we started to look at a lot of IO related questions in the early stages of when the scanner data products became more widely available, it started to gain traction. And so now we see a lot more applications for research projects, program evaluations, such as program evaluations of SNAP and WIC, looking at regulatory impact analysis, things regarding changes at the federal and state level to certain policies, and then also using scanner data products to create other data products. Generally speaking, the fourth item here about generating data products from the scanner data, we see that mostly done at the USDA. And again, just to note that collaborating with the USDA has a lot of advantages, especially if you are more of a metrics person and want to create new metrics using data. That would be a really great partnership. To get a full sense of all of the published literature or working paper and even pointing to published literature, I point out a link here to SSRN. Kiltz puts together a white paper series. So it really does give an exhaustive list of all the papers that have been written by users with an academic subscription. And I'm going to be going through a few of those examples today, including one of my own, or a couple of my own. So here's just some stats on what you might see when you come upon or go into the SSRN site. There's approximately 535 users that have published their white papers, lots of collaborations going on, 337 papers, and a lot of downloads, a lot of views, a lot of things. And just to give you a sense of run the gamut, we've got things like looking at TV advertising effects on profitability. We have some of the top cited papers, Food Deserts and the Causes of Nutritional Inequality. That's a paper that I cite often myself. It's actually published in QJE. And that actually was two papers that ended up becoming merged, and they look at how demand and supply side factors explain nutritional disparities among low-income households. So this question of does poor food access matter in nutritional disparities? And they find that actually supply is not the primary explanation in the variation of nutritional inequality. It's actually the demand. So it seems to be that households who don't want to eat healthy don't want to eat healthy. And that's going to explain a lot of it. So really interesting ways to use that, to use the data. And they look at tracking households and availability of food and their purchases to measure each one of the inputs for the modeling that they do. Okay, so switching into looking at the architecture of scanner data, I'm going to talk about two primary data products that Nielsen provides through the academic subscription. We have access to additional data products that Nielsen supplies through their academic subscription that I don't talk about here, which is an advertising data set and also a promotion data set. And I can talk about that, after the talk, but I do want to talk about the retail data and the household data. So the first product, the retail point of sales, it's weekly item level sales for packaged foods. And these sales are reported at the store level. So Safeway located in a particular area is going to appear in the data every week. And every week we'll see which UPCs were sold. And that includes a number of things about what items are sold, but also the quantities that were sold and the prices of those products during that particular week. And we have a product dictionary with item-specific attributes that we can use to identify which products are being sold, not just a barcode, as you see here on the right-hand side of the slide. And then we've got household panel data, and this is a nationally representative household consumer panel. And we look at, I look at food retail purchases, but they do have purchase data outside of food items, including things like cosmetics and whatnot. But these data are reported daily in multiple times a day. So it's literally every single purchase that's recorded by a household is scanned, and we can see which household is buying it at exactly what time in what store. And we know a number of demographic bits of information about them that I can share, that I'll be sharing in a moment. The UPC, because this is scanning, you have to scan something. What are you scanning? You're scanning barcodes, or UPCs, universal product codes, alternatively called SKUs or stock keeping units. There's various nomenclature for that. So the retail product dictionary is shared between the retail point of sale and the household panel data. So that makes it nice to be able to compare the representativeness of expenditures between the two data products if you're so inclined to do that exercise. So the retail scanner data, a little bit more about it. We've got at ASU, we have a university subscription, and I'm the contract administrator for that data, which we house at WP Carey. We have available the data from 2006 to 2020, and the 2021. Every year the data comes out about, it's a 2-year lag or so. So we'll be getting the 2021 data probably in the beginning of 23. The unit of observation is the store UPC week level. And we're looking at units, meaning the quantity of items sold, and then the price, meaning the total dollars of the food, in my case, food item, but really it's any item sold in a week. The retail scanner data it doesn't record every single retailer. So that's just a major caveat of this particular sample. We're looking at about 20% of store locations across the United States, or 20% of retail chains, which capture about 50% of total food sales. I don't know the stats outside of the food sales. So I'm looking mostly at the food data, but there are a number of papers that look at comparing the retail scanner data with the U.S. Consumer Expenditure Survey, which is a bit more representative of the U.S. Consumers' purchase and sales across the United States. And that data product, the Consumer Expenditure Survey, is collected by the U.S. Census. And in order to access that data, you have to go behind like a closed curtain, and you can't really get that data without getting a special clearance. So given the constraints or the barriers in access, the retail scanner data, one caveat is that we're looking at about 50% of sales covered by about 20% of store locations. These store types include grocery, club, supercenter, convenience, dollar stores, and drug stores. So we're able to identify at which stores are classified according to format. And that's an important distinction to know where people are shopping, especially regionally, and looking at volume of food sold according to these different retail formats, because we're seeing a lot of changes in how the competitive landscape across formats has changed, especially recently with certain retail formats, being able to accommodate food items that need to be refrigerated. Like I said before, too, we've got some detailed product information, which I'll show in a moment. And another important point about Nielsen's data is that the store location information is really is only available at the 3-digit zip code. If anyone is interested in partnering with the USDA, the store level data is down to the latitude, longitude. So for some research questions, that distinction is very important. For some other research questions, it might not be as important because of the aggregation, the spatial aggregation might matter. For this particular data, it is strongly recommended that users have at least basic standard query language SQL coding proficiency in that. When after one downloads the data, I'm using a program called dbeaver, which is a SQL. It's a database management software. I load it. It's almost like the backend for Microsoft Access. So what you're looking at here is just a snapshot of how the data come. So this particular file is called the movement file, and this is tracking store level UPC, week, units, prices, and then a few other pieces of information that are important to know regarding whether the item was on promotion that week, if it was end of aisle, display, different placements in the store. These variables will have different meanings. We look at a product module, meaning what item was it, or what aisle was it sold on? Oops, gotta go back here. What aisle was it sold in, or what department was it sold in? And then we have a year indicating. It's just basically I created that based on this week variable. So it's really fun to see the behind the or under the hood. So that file I was showing you is the movement file. So this middle square here, but all the retail data is it can be merged. That the files come, or the data comes in different files. So we've got a movement file, which is all those store level sales. We've got a store file, which links based on the store code, what format and location, so that whether it's a grocery, et cetera, and then that 3-digit zip code I mentioned. And then we've got some product information files that can be linked on the UPC. So we can tell things about its attributes, and then more information about what actually the product is described as, which is a text string. I think I have that in a moment. And then information about which aisle it's found in the grocery store. Questions before I turn to the household data? Anyone over here? Okay, we're good. Nice. All right. So the household scanner data, we have a slightly longer period. We've got 2 extra years, 2004 to 2020. And the unit of observation is the household trip UPC. The neat thing about this data is that IRI and Nielsen, this was a joint venture between the two of those data proprietors. So that joint venture is actually called the National Consumer Panel, and they basically created a mechanism so that they could collect households' purchases, wherein the households would scan their purchases at home, and they do this solicitation so that they can capture the sample of households. About 200,000 households have participated in this National Consumer Panel, and about 60,000 households of those 200 appear in more than 1 year. This is another important distinction or note that I want to make, because a lot of the papers that have been published in this space, especially in the food policy arena, like to track households over time, because we want to understand. I mean, if we're looking at an effect or looking at the effect of an intervention on on an outcome at the household level, we need most of the time we need more than 1 year of data. We can't, we can, to some extent, we're also, a lot of the papers published in this space are looking at natural experiments, and sometimes those outcomes are only realized years after a particular event happens. So being able to track households from 1 year to the next is really important. And 60,000 households, it's still a considerable portion of that, given that in order to get 60,000 households to fill out a survey either is costly or, to track them over time. There are a lot of constraints with that. We have information on a set of demographic characteristics at the household level. That detailed product information that the retail scanner data uses is also able to be joined here. And here at ASU, we're looking in January to purchase additional health data. So this is called an ailments file, and it'll give information about households who might be diagnosed with diabetes, their BMI, other things like that, looking at their medications so that we can look at, establishing relationship between certain types of food items purchased and their association with possibly health outcomes. The household scanner data tables, the files, they come in, again, a number of files. The three primary files that are particular to the household are this purchase file, a trip file, which is an aggregation of all of the purchases that the household makes, all the aggregation of the item level purchases at the trip level. And I'll explain more of these in a moment. And then we've got this panelist file, which is a demographic information. And again, those product files on the bottom left here are going to be related to the attributes and the descriptions that can be joined by certain variables in that purchase data file. This is just kind of like a high level thing. And if you're familiar with Microsoft Access 2, you can maybe imagine how this would all work out. The purchase information, specifically, we've got two files, the trip table and the purchase table. The trip file is going to be an aggregate file of all purchases made during a single trip, and it's delineated by a trip number, a store code, the date of purchase, the total amount spent, and then we also have information on the method of payment. So we know if they're buying their items, if they've used cash, check, credit, debit, and we actually know which credit card company they use too. So if you're a finance person interested in looking at, the use of credit, or even looking at, any sort of even food assistance, I can imagine too. There could be some interesting questions to look at there. The second file that we have that's related to the purchase information is the purchase file, and that records those records are assigned to every household, each with a unique ID number, and these are going to be disaggregated, the disaggregated trip file. The trip number itself is going to be used to link it back with the trip file. The interesting thing about this trip file too is that households often shop more than once on a given day. And you can imagine that, apply that to your own life too, that how many times can you go to one store and get everything you need, but you're already out shopping, you're going to go to another store. So it's interesting to look at trip chaining questions, looking at retail agglomeration questions to see the importance of local substitutes or complements in store arrangement to see about, how are households taking advantage of the location decisions of retailers. We've got information on the quantity of the items they purchased, the total price paid. We know also if they used any coupons or whether the product was purchased on promotion. And I'm going to show you, this is that purchase file. So we have a trip code in the far left column, the UPC, UPC version, UPC and UPC version. If you want some technical information on that, I'm happy to share. But the long and short of it is that food manufacturers or any manufacturer might they buy blocks of UPCs, almost like real estate. They buy like a building, and that building might have like 4 storefronts in it. So think about UPCs as being that building, and they might have 10 storefronts or 10 blocks, 10 individual UPCs in that block of UPCs. And so sometimes though a product might get discontinued, but the food manufacturer may still own that UPC, but they might reformulate it. And so that they might recycle that UPC, but it would be an updated version. So you can actually see in row 30 here, or even 27, this is a UPC version number 2. So this particular manufacturer could have reused that UPC or reformulated it in some way. And there are a good deal of papers out there that look at product reformulation, on prices, on like questions regarding, the health effects or the health quality of the foods once a product is reformulated. So one would be able to look at product reformulation by taking advantage of this particular UPC version. And then again, quantity, price, coupon value, deal, and then I have a little year variable here that I created from the trip code. Okay. So back to that product dictionary. This product dictionary is shared between the retail and the household data products. And these are for UPC food items. So any sort of random weight item that doesn't have a barcode, we won't see that in our data. We're going to see anything with that barcode. Attributes. So we've got products for over 500 million UPCs. I don't have the breakdown of which of those are for food items, but these 5 million UPCs are for all products. And we know information about their description, the brand, what their volume is, product categories. We know from this extra file, we can tell what type and flavor they are. So it could be, a type would be, we have carrots, we've got baby carrots, and then probably no flavor, because I don't really want to try flavored baby carrots. But you can kind of get a sense of like the form of the product, and then maybe flavor would be something like, I can't think of anything off the top of my head. The other attributes that are important in this space too could be things like, does it have a USDA organic seal? We also have some information on the nutrition facts panel that's very limited in the Nielsen data. For example, I believe the most represented item on the nutrition facts panel is that salt content information. The USDA data has a lot more nutrition data, but hopefully we'll get more as Nielsen provides more things. And here's just an example of that product file. We've got the UPC, the version of the UPC, the item description, which is all in text. So if somebody is working with sort of like good with text string analysis, there can be a lot of information that can be gleaned from this particular variable by combining it with information about the product module and things. And that's sort of the breakdown of it. Demographic information includes things like male and female household head. So who is the head of the household? If it's a single family, a single parent household, we can discern that from the data. We have information on how many members are in the household, and then also the age of each of the members of the household. So we can identify if there's children under the age of 18 or children under the age of 2, which has relevance for certain policy questions. We know the type of residence, if they're renters or owners. We have a range that will indicate the annual income for the household. We have race and ethnicity variables, identifications. For the panelist information, we have 5-digit zip codes as opposed to the 3 for the retailer. We know if the household has kitchen appliances, which is important for looking at questions around food access. And then we have a WIC indicator, not a SNAP indicator though. So unfortunately, we don't have that. The other thing that they do provide are projection factors, or said another way, it's their survey weights. So for every household that's reported in the panel, Nielsen and IRI, they create these projection factors so that we know approximately how many households that particular household represents. So I'll show you that. And this is really great when doing regression analysis. So here, for example, we have a household code all the way on the left-hand column, and then the projection factor is in the third column. We can see that this particular household, its purchases represent approximately 2,858 people in a specific market area. So it's nice to see, okay, this one is most closely like the average, or this, some other household, maybe in row 4, their purchases might be a little bit different than what others are purchasing, given the observable characteristics that they create these survey weights from. Yeah. Okay. So a few limitations about the data before I go into the applications is that we do have limited information on non-UPC items and random weight items. So anything, it turns out that to be that it really underreports fruit and vegetable purchases. We don't have any record of transactions at food service establishments. And, households, they do purchase food, 50% of their food budget goes to food service. So we're getting we're just getting these food at home behaviors. And the retail level geographic identifiers are quite aggregated. There's a 3-digit zip code, like I mentioned. We have less representation in non-metro areas and certain parts of Central America. And then the demographic information, you can see it's quite rich, but it's certainly not exhaustive. And indeed, one would have to do some simple but clever manipulation to create new demographic variables using the data that exists, such as the age of the household members can be constructed from the data itself, but they're not necessarily supplied to us. We have to create those measures. So just, thinking about the time requirements before embarking on a question. Often, as a researcher, as an empirical researcher, it's just a matter of when am I spending the majority of my time? Am I spending the majority of my time in prepping the data or in designing a research survey? I mean, no matter what, in order to answer a research question, I'm going to have to spend time creating the analytical sample that I want to use to answer my research questions. In this application of using scanner data products, a majority of the time is going to be spent creating the data set. And then it's almost underwhelming because you run an OLS and that's it, or you do some kind of instrumental variables method and, then it's done, but you're going to spend a lot more of your time actually building that data set. So some benefits and also some things to note is that sometimes you might run into a challenge or you want to look at something in more depth that, aren't really collected by Kilts or through Nielsen, or maybe Nielsen does collect it, but it's not available through the academic subscription. Researchers are able to talk to Kilts and ask for doing some sort of add-on services to collect additional data. This would be an additional fee, but we've seen there's a survey that's collected that looks at the tax returns for a certain subset of the households. And so that is available, that product is available for purchase, but the reason why that product became available was because researchers wanted to have additional information about the occupation for households. And so because it was such a good idea, according to Kilts too, and they decided that, okay, we're going to make this available for for researchers as well. So there's some economies to be gained for that as well. And another benefit is the linking the data. I mean, there's so many ways that this data can be linked with other data products. And for example, UPCs can be linked with a number of data sets. And I'm just listing 3 here, looking at new product, the global new product database, which is a Mintel product, to see, this idea of, to what extent does demand predict new product entry? We can look at things like the set of products that have been newly introduced. We can probably calculate that using the data, but this is a much cleaner way of doing it. USDA's Global Branded Food Products database does offer a much richer set of product level attributes, and that's publicly available. The label insight data is just recently has just been recently acquired by Nielsen, and that's going to give a lot more information on front of package information, seals, all the things that don't appear on the nutrition facts panel. And then also geographic identifiers. Even if it is just a 3-digit zip or a 5-digit zip, we can link those to a variety of census data products. And also because zip codes can be overlaid with certain MSA or metropolitan statistical areas, even in the demographic data and the retail data, we have a market level variable, which can be used to link with Google Trends data. So we have a research team here at ASU who's using Google Trends data, looking at supply chain for produce items, of marrying the two. So this is a very interesting and neat application, which I won't be presenting today, but that's what they're using to link. Questions for now? Okay. So I'm going to kind of wrap up with 4 applications of data, the scanner data that's been used in food policy research before telling you how you can access the data. And these are some of my colleagues. So I'm going to give them credit and I try to represent them as much as I can. They're some of my favorite papers that I've read using the scanner data. So this first one is written by some authors, written by some colleagues at Cornell and UMass Amherst. And so the major motivation behind this paper, welcome, hi, was looking at this question of genetically modified organisms. And there's been a considerable debate around and apprehension by households to purchase foods that have been disclosed as being GM. And actually about half of US households, when surveyed, believe that foods containing ingredients with GMOs are less healthy and less safe than foods without GM. And industry is responding because there's really there hadn't been or hasn't been really, except for maybe one study at Stanford, any study that really substantiated those concerns expressed by households. So, when we think about disclosures for GM, my mind goes to labeling. And there are 2 ways that industry can respond to labeling. Either they voluntarily label foods, or they're mandated to label foods. So it turned out that there was the non-GMO project that was a voluntary group of food manufacturers that adopted a non-GMO seal, and that was a voluntary label. As for mandatory labeling, the only state that it was relegated to the states, and the only state that ever passed a law to mandate GM labeling was the state of Vermont, and that was in 2016. It was only in effect for a few months before it was overthrown because of another preceding law. So this pointed to a very interesting natural experiment for which the scanner data covered that time period. So these researchers wanted to know, well, what is the effect of GMO labeling? Because they had information to be able to discern between voluntary and mandatory labels. What was the effect of GMO labels on consumer choice? And then how did it change in the supply composition of non-GMO products? Or how does the change in the composition of non-GMO products affect consumer purchase behavior? Because of course, food manufacturers are going to want to, adjust the way that their products are offered and displayed and labeled in response to all that attention. Oh, okay. There's a microphone here. So what they did is they used Nielsen scanner data, and they looked particularly at ready-to-eat cereals. They linked UPCs with the non-GMO project verified program, and that was to identify all UPCs that had that voluntary label. And then they used also other controls, such as an organic indicator, because if a product is labeled as organic, they're also inherently non-GMO. And then they used the Vermont law passage as an event or the treatment in a difference in difference model. And they also did a synthetic control model to measure changes in GMO market share from before the Vermont law was passed to after it. And they found actually that slightly decreased, GMO market share decreased by about 5%. And then that non-GMO market share increased by 33%. But it turns out that the increase in the non-GMO market share was primarily driven by the attention that the law was generating in the area, not actually from the mandatory passing. So the paper goes into a lot of depth about it, but it's really interesting that, using this scanner data, they were able to look at really what is driving the changes in market share of those products. And this is in the ready-to-eat cereal industry, cereal products. So we don't necessarily know of how this market share would change if the product category itself changed. But this paper is available in Marketing Science. So really top-notch journal, really great paper. I recommend. The next application using this data is looking at food retail competition in local markets. And this is more of a methods paper. So if maybe this will be interesting to some of you. These are with some colleagues of mine at the University of Minnesota and the USDA. And the idea here is centered around consumers' willingness to travel to grocery stores or to stores, food retail outlets outside of the grocery sector. And we have some information here that households on average like to travel no more than 8 miles to purchase their food. And traditionally in the literature on food retail competition, we think about setting markets, defining geographical markets of competition a priori. So we don't actually think about, or in the modeling approach, we tend to say, okay, in this particular zip code, retailers are competing with each other. But as it turns out, when talking with industry, is that retailers really do capture more of their market, or the markets are kind of amorphous. So they change depending on the relative rural status or urban status. And because of that, they're going to be tailoring their pricing strategies according to their local markets. And so retailers will use prices to either enhance competition or soften local competition, because they know that their competition might be in some areas more concentrated. They might be more, the competition in an area might be more concentrated, meaning that they'll be able to charge higher prices perhaps. Or if they're in a very competitive market where there's a lot of substitutes for that particular retailer, they're going to want to soften those prices so that they can capture a larger market share. So a lot of those mechanisms, those mechanics, they were not necessarily very widely used in the literature. And so these researchers wanted to look at, well, what if we start to play around with the area or the definitions of market areas? How does grocery retailer competition change when we think about changing the spatial area in which retailers compete? And then they want to quantify how estimates of household demand elasticities and store level profit margins vary with those different definitions of local market areas. They're using both household and retail scanner data. They in order to calculate elasticities, we need to have a shopping basket price. So they calculate a unit price, kind of an index for a shopping basket. And then they estimate a series of structural models of demand and supply so that they can calculate what would by changing the market area, the definitions of how market competition is defined, how does that change elasticities? And without actually accounting for local competition, price elasticities, demand price elasticities are overstated or overestimated, which means that consumers are actually in traditional models appear as more sensitive to price changes than they actually are. Because if you think about it, that makes sense too. If I see that in my area that prices might be a little bit higher, I'm willing to travel a little bit farther away. And that distance, that willingness to travel increases as my income decreases. I'm willing to travel a little bit farther to be able to get the price that I'm willing to pay on specific items. And when they looked at profit margins, store level profit margins, they found that they were underestimated, because retailers they find are actually more profitable than in the alternative scenario. So meaning that profit margins are underestimated. Let's see here. So without accounting for local competition, they're underestimated. So in fact, retailers can capture a larger market share than we might otherwise think they are. And these results I found to be quite informative, because they do have implications on assessing the effectiveness of food policies, particularly any sort of food and beverage taxes and retail subsidies. Because if we know that a household or a certain area is going to put sugar sweetened beverage taxes, but households are willing to travel farther away because they're price sensitive, they will do that. So interesting paper. One that I wrote was looking at this question of poor food access and product assortment. When this paper was published, at the time we estimated, or USDA had estimated, that there were approximately 24 million Americans that lived in areas with severe food access limitations, meaning that their neighborhoods in which they lived did not have access to supermarkets or large grocery stores. And that was, that's a huge number. It's approximately the population of Australia. And what we found, or what we saw in the literature, is that there's a lot of extensive analysis of is there a store, or isn't there a store? But what if a household lives in an area with poor food access? Do they also have fewer healthy food items to purchase when they're there? And there was nothing documenting this at a national level. So we wanted to look inside the stores in the areas that were classified as these quote unquote food deserts. So with the scanner data, we're able to look at inside the stores, not just what stores are there, but what products are being sold. So that's what we're doing in this paper. And we use both, we're actually predominantly using retail level scanner data, and we're able to link that with the Food Access Research Atlas and to classify these areas without supermarkets. And we found that poor food access and poor product availability are positive and statistically significant, the relationship between those two. And the results are meaningful, because we find that households who already face constraints in that they're not able to shop outside of their neighborhood to access food, like say they're relegated to non-traditional formats like the dollar stores and the convenience stores, they're also less likely to have access to healthy food items, which again had not been documented on a national level. And for households who are constrained without access to vehicles, especially in certain parts of urban, rural areas, or anywhere from urban, suburban, and rural areas, it can have differing effects when we think about the geographic variability of the United States. So that's the paper that I worked on. And then the last one I'm going to present today, share today, is one I'm currently working on with a professor in the College of Health Solutions and a student that we hired as a research assistant, who's a computer scientist. And we're interested in understanding the health motivators for households to purchase plant-based, to switch to plant-based options. Why are we interested in this? Well, from even just looking at the scanner data and also just reading the news, consumption of plant-based products has grown significantly. The reason why people adopt plant-based items is generally classified, considered to be three reasons, maybe all or not, or one, but it's for health, animal welfare, or sustainability reasons. So we're really driving into this health aspect, and we want to estimate the effect of. How we're doing that is we want to estimate the effect of a diabetes diagnosis on consumers' decisions to switch to plant-based meat or plant-based dairy. And in doing so, we're also looking to explain how consumption of different categories of plant-based products has changed over time to see whether consumers' health motivations drive the adoption of plant-based diets. And we're using all the years of data. We're using our artillery for this particular question. We're using the 12 terabytes of retail level data. We use an 18-year longitudinal panel, the entire 18 years. And we're using data that we borrow from the Plant-Based Food Association to classify different, the UPCs according to which product categories are most likely to have substitutes in the plant-based. And then we're using the global branded food products database. And then we're using some machine learning to identify potential diabetic patients based on their purchases of diabetic products. And as it turns out, we do see that households who have been recently diagnosed do increase their purchases of plant-based milk and plant-based meat. So we're going to be diving into this a bit more robustly, doing some econometric modeling to look at other related questions. So those are some applications. And in the last few minutes of my time, I will share with you all how you can get your hands on it. So there's roughly 4 steps. First is you want to go to, hopefully these slides will be shared, but you're going to want to go to the Kiltz Marketing Data Center website and this particular hyperlink that I have embedded in here. And what you're going to do is you're going to search for Arizona State University. There's going to be a little dialog box and you're going to type in our ASU. And then you'll be directed to a page where you're going to complete a request form. Then that request form is going to get routed to me. And your request will be approved and you'll be given further instructions on how to go forward. We do have a bit of a pricing schedule that is a shared cost. Every year to purchase this data, it's $10,000, which is not a lot of money for the amount of data that we're getting here. And so the more people that use it, the lower the per researcher cost. And we've got, I'll show you who's all using it now or in a moment. Then once I approve it, it's kind of out of my hands. So I have no control over whether you get the data or not. Then you're in Kiltz's hands and you have to write a detailed project request template, really being very detailed about why you want to answer this question, what's been published in this space, how are you going to do it, what data sets do you need, why do you need the data sets, all these questions I can advise on to some extent. And then that's going to be reviewed by Kiltz. But most of the time, as long as you're not, being cavalier with the data, or indicate or have any red flags with that, they think for the most part, they'll approve your request. And then from there, you'll be instructed on how to get access to the data through a secure transfer network, which is through Globus. And we all the data has to be stored on university computers. And I think because we have unlimited Dropbox, it doesn't really seem to be too much of an issue. At Agribusiness, we have a server where we store all the data. A couple other piece of information, students cannot request access. It has to come from a PhD or faculty member or somebody who is employed by the university, essentially. Every researcher, a primary researcher, is allowed to have 2 research aides or research assistants affiliated with their account. So if you're working on 20 projects, you can still only have 2. It's not per project. If you're working on 1 project, you can have 2. So that's just something to note. These data cannot be used in teaching at all. So that's something that is, for better or worse, but probably for, the way I think about it, I would love to be able to use these in the classroom, but right now the data cannot be used for teaching. Data must be stored on university-owned computers or servers and then must be destroyed if no longer using or upon leaving the university. Each researcher will be asked to contribute to the cost share model that we've established at the business school so that we can maintain our university subscription. And then separately, I myself am working on building courses on how to use scanner data for approved faculty and PhD students and postdocs. So that should be, and that's in the works probably over the next year, 2 years. Those information on that will be shared. And then here are all the departments that have faculty and PhD students currently using scanner data. We've got outside of agribusiness, marketing, accounting, IS, College of Health Solutions, and then Fulton's computational and augmented intelligence scholars are using that. And that's it. Happy to answer questions.